Now we're going to do the same thing we did for vertex form and standard form in starting out in factored form. We're going to determine all the key features from factored form. Now recall that the ones directly obtainable from the function are concavity. The function we're looking at here is f of x equals x minus 4 times x minus 10. A is positive, so we're concave up with a minimum, and we were able to determine our x-intercepts, 4, 0 and 10, 0. What we're going to do from here is we're actually going to not worry about it being in factored form. Step 3, we're going to multiply those two factors, which is our step 2a. We're going to put our function in standard form and then follow the standard form procedure. So in this space underneath here, I'm going to rewrite the function. It was f of x equals x minus 4 times x minus 10. And we're going to multiply those two binomials out, which is then going to give us the standard form of the function. So x times x is x squared. X times negative 10 is negative 10x. We'll multiply negative 4 times x to get negative 4x, and then negative 4 times negative 10 is positive 40. Add those two like terms in the middle, and our final simplified function here is f of x equals negative x squared minus 14x plus 40. That's our standard form. So let's go back to the idea of our a's, b's, and c's for standard form. In this case, a is equal to 1. That's our a value. B is negative 14. And C is positive 40. Notice that I highlight the number along with its sign, whether it's positive or negative, but not the variable. We only want those numbers. That's those coefficients are A's, B's, and C's. So I can really almost ignore that factored form column now and go straight back to standard form, because that's what's going to help us here. So we're on step 3 now. We're going to find that axis of symmetry. The equation x equals opposite b over 2a is exactly what we need. For this function, a is equal to 1, b is equal to negative 14. So I'll substitute those values back in. The opposite of negative 14 is positive 14. So that's equal to 14 over 2 times a, which is 1. Let's highlight those in the colors that we used. A was pink. B was orange. Remember, you're filling in your notes. Pause as needed. And then you're going to do the other column on your own. Make sure to simplify your numerators and denominators before you divide. 2 times 1 is 2, and that leaves us with x equals 14 divided by 2, which is 7. So axis of symmetry, x equals 7. So we finished our step 3. What we do then is we take that x value and we plug it back into our function and evaluate. So let's come back up to this section here for the vertex. We know that x was equal to 7, so we want to figure out the y value when x is equal to 7. So we input the x value of 7, so we find f of 7 equals, and I'm actually going to use the standard form. You could plug that 7 back into the factored form of the function, but I just find it easier to use the standard form that we came up with down here. So we're going to use x squared minus 14x plus 40. X squared minus 14x plus 40. So 7 in both of the spots where there should have been an x. Remember, I used parentheses. You can put that right in the calculator. Or we know that 7 squared is 49. Let's see, 14 times 7, negative 14 times 7 is 98, negative 98. All right. Add our 40. 49 minus 98 is negative 49 plus 40. F of 7 then is equal to negative 9. So our vertex, the x value, came straight from that axis of symmetry. X was equal to 7. the output y value is negative 9. We get a vertex of 7 comma negative 9. And then finally, we're able to figure out the y-intercept. That was step 2 when we had standard form. That comes straight from the function. Once you know the standard form of your function, the y-intercept is your c value. So our c value is positive 40 in this case, so the y-intercept is 0 comma 40. And then what I'll have you do is complete the right-hand column for that other function. So you're going to do the same thing for f of x equal to x minus 3 times x minus 7.